Texas Algebra 1 test. And we begin by showing some artwork created in the Desmos graphing calculator. This one by Samuel Obigbasan of the United Kingdom. Let's go to the first question in this series. The table represents, it's also a table question, the table represents some points on the graph of an exponential function. So the first two questions are going to be table questions. And this one shows clearly that the x is on the left, y is on the right. It usually will be, but make sure that you read the table correctly, and that is in fact x and y. And function of x, as we have said before, is represented as y, or y is represented as f of x. So that's your y column. And let's go over to the Desmos calculator. Okay. And let's clear these old values out and begin plus add a table. And our table is -2, -1, 0, 1, and 2. -2, -1, 1, 0, 2, where is it? 0, 1, 2. 1 and 2, and then the y column is 12.5, 15, 18. 12.5, 15, 18. Careful how you enter them in. And 21.6. And 25.92. Okay, so we have a feature here. So we've got our points. Let's take a look at where they ended up. Okay, there they are. And to better visualize it, to better have a look at what that line looks like, we actually have a feature here that you switch on. You look at the circle by the y column, and it's going to say line, and you switch that line on, and you can get a better look for where your values are and what that line looks like. So go ahead and let us read the question. And it says, which function represents the same relationship? Same meaning an equal relationship. One of these four options is going to equal the line or the figure that was made by that table. So let's start with the first one, okay? And it is the function of x equals 5/16, okay? And function of x is also saying y equals, and then we have our, let's see, open up our keypad to get our, what was that fraction, 5/6. The divider sign, the division sign creates the fraction 5/6. And notice that there is an exponent. So this letter here gives us allows us to put in any exponent. And that's the line of y equals 5/6/x. Enter. Okay. All right. What does that look like? Okay. Oh, we have something is missing. 15 times 5/6. All right. So you got to make sure you copy that right. Okay. So in my next one, that doesn't look the same, does it? So my next one, it's 18 times 6/5. All right. I'm just going to copy this here. And this equals 18 times 6/5. Okay, and in fact, that hits right through the points that we were looking at in the table. You turn that off, you see that the values in the table match exactly. That answers our question of which function represents the same relationship. So we're confident in choosing B. Okay, we'll look over at our answers. And that's 31, and the answer is B. Thank you, Desmos. We have another table question. We've seen this just before. The table shows the amount of pet food in cups remaining in an automatic feeder as a function of the number of meals the feeder has dispensed. So we have an n on this column, and we have a function of n that shows that this is actually a y. So we have an n, which is our x column. A function of a number is our y column. And we only have 4 fields this time. We have 4 rows this time. Let's put those into Desmos. Again, we hit the plus. new table. And again, we are using the testing version. So this is what you can see on the day of the test. A lot of features have disappeared, but you can see right there that we can use a table. Okay, so we have a 1, 3, 6, and 7. 1, 3, 6, and 7. And on this side, we're on the y column, function of a number, 21, 15, 6, and 3. 21, 15, 6, and 3. Okay, so we have our points plotted out, and we can get a visual on that. We can see the line by, once again, hitting the circle and switching on line, and this is what we get. And this works in a Chromebook, this works in an iPad, and other features that support the Desmos calculator. Let us now read the question. Based on the table, which function models the situation? Now, instead of using the word same, we have the word models. Okay, so it's pretty much asking, as in before, which of these choices best reflects the line or the figure that was created for us in the table. So let's go in, and fortunately, this looks to be like it's in standard slope form, and actually it's called the slope intercept form. I use the word standard perhaps wrongly, because according to the chart, if you look here, okay, the chart calls this the slope intercept form, and the quote unquote standard form is that form, and we'll see that one later. So take a looking at that. We're going to enter our equations just as we see them in the test. Okay. Here we go, and that was question 32. So function of n equals -3n plus 24, and I don't like function of n. I actually would like you to use, and like my students to use, the y equals, and make sure that you have that copied correctly. -3n plus 24 is the first one, and note that it goes right through those points. It goes right through those points. In other words, do we need to continue with B, C, and D? Well, if you feel better about entering it and making sure you rule them out, that's fine. Y equals, and we have 1/3 n. Okay. And you can see that you can rule out the rest, but I'm pretty confident in determining that it's the first one, and I won't go on with the rest of them. You can see they're going to be different. This one goes right through the line that was created in our table. That is option F, the very first one. Let's choose F. Go over to our key, and that is 32. Answer is F. And once again, Desmos has readily done the math, the figures, the values, and you just answer on the bubble sheet or in the answer sheet. The graph of function of x equals x squared was transformed to create the graph of the g of x equals the function of x minus 9. Which statement about the graphs is true? So we're talking graphs, we're talking Desmos, or whatever calculator you happen to have on the day of the test. I strongly suggest, in my humble opinion, this is a great calculator to have on the day of the test. You can use it in addition to the other calculators that are available. You do not have to replace it. You can use it in place of or in addition to. So let's see. So this looks like our standard quadratic, right? Function of x equals x squared, or y equals x squared. And I put that on our graph. Let's clear out our Desmos. And we are given that y equals x squared. And that's a classic parabola. Don't forget your square. There. Okay. So in this one, and again, it helps to do these questions. See these questions, keep doing a number of them that appear from previous exams. Some of your materials that show actual state questions, in this case, a STAAR. And so when I looked at this, I was reading this as some other number. Again, it gets confusing. But you're saying that the graph of the g of x, graph g, in the G, with the value of G of X equals that value there in this graph, minus 9. So, okay, so let's make sure that you understand that this value here is now going to appear over here, so that this new graph, whatever the figure is equal to that function, that value minus 9. So let's try that out. Let's go ahead and go to our Desmos calculator and say that now we have a function of y equals this value minus 9. Okay, so let's go down. All right, so we have another parabola. Okay, and let's make sure we copied it correctly. Function of x minus 9, function of x minus 9. Okay, function of x minus 9, and that's how we read this chart, this information, so that the question, so the answers here have to match something on in this information. The question is actually which statement about the graphs is true. So one of these statements, and only one, will be true and completely true. So let's just pick them one by one. Observe something in this statement that is true or completely true or false. The graph of G is a reflection of the graph of F across the x-axis, and this is the graph of G. So we'll look at that. The graph of G here is a reflection. Now, reflection, you know, means a mirror image. And so if I'm looking at my camera, many cameras will give you the mirror image, and sometimes we take selfies and we have to flip them over in some other software, or in the iPad or in the phone, it has to flip it over because you're actually seeing a mirror image. Okay, in this case, it's not a mirror image, it's not a flip. There seems to be a move somewhere else. So we can rule that one out. And so we don't think that one is true. Okay, and so we rule that one out. Okay, looking at the next one, the vertex of the graph of G, the vertex of this G is 9 units to the right of the graph of X. So let's take a look at the vertex of the graph of G here. Okay, the vertex is down here at 0, -9, and it says 9 units to the right. And in fact, it's not 9 units to the right? It would be somewhere over here if it was to the right. If it was to the right, it would be over here, but it's not. So we can therefore rule that one out and say we don't like that one. It's not true that it's 9 units to the right. Let's move on to the next one. The graph of G is a reflection of the graph of X across the x-axis, and we ruled out in the first one that this is not a reflection. So it's still not a reflection by the time you get to C, and we can rule that one out. So we're getting to the last one, and we really hope that we did our values right, we set up our equations correctly, because we only have one left. And that one says the y-intercept of the graph of G, the y-intercept is 9 units below the y-intercept of the graph of F. And let's look at that. And so let's look at the y-intercept down here. It's this point here, the lowest point on that parabola. And we said before, it's 0, -9, and it's marked clearly there. And so -9 here, and the value of the vertex of the first parabola, our original equation, is at 0. So 0 to -9 is indeed 9 units below, 9 numbers below the y-intercept of the graph of F, the original graph. So we're comfortable in knowing or determining that D is the answer, and we go to our answer key, and that was 33 is D. So Desmos did, again, a lot of the heavy lifting, and don't take it for granted. This is a great resource to allow you to determine the values, illustrate them, and determine the truth of what the statements are in relation to the graphs that you're given. The expression x to the 22nd, the power of 22, multiplied by x to the power of 7, which is itself raised to the power of 3, is equivalent to x to the p. What is the value of p? Okay. And I don't have answers to guess and throw away because it says record your answer, fill in your bubbles on the answer sheet. So over here, what we have to know is there are two rules in effect here. The rules of x for multiplying exponents. And so, or the rules for multiplication when exponents are involved. And let's talk about the first rule by saying, we have our given. We have our given. And so let us do, so we're given x to the 22nd. And you don't have to do this, but you can make notes somewhere. X raised to the power of the 22. Okay, so we're gonna leave that for later. So then we also have x raised to the power of 7. So given that x is raised to the power of 7. Enter that in. Okay, so we're further given that x is actually raised to the power of 7, and then that is raised to the power of 3. That x to the 7 is raised to the power of 3. So we hit this letter here to give us another ability to put a power. So again, I put the x22 to the side, x to the 22nd to the side, because I want to deal with this rule here, which says if x to a certain power is raised further to another power, then the power above, the exponent above, is multiplied by the exponent of the variable here. So what that means is I'm going to take this x here, and I'm going to take its exponent, and I'm going to multiply it by 3. So I'm going to take the exponent 7, and I'm going to multiply it by 3. Okay, and that gives me 21. So I now have x, this is just a note, x raised to the power of 21. Okay, it makes us a type of figure, but we put that to the side for now because we only want to know that x to the 21 is the result of x to the 7 raised to the power of 3, correct? Okay, now we have our x to the 22nd. So we take that x to the 22nd, okay, and now we are going to multiply that x to the 22nd by this value here, x to the 21. Okay, now the value is not calculated, right? Because I don't have a function or a figure that says the value of these, right? I do have a graph. But what you must remember going into the test, that when you have two like variables, right? These are two like variables, an x and an x. You take their exponents and you add those together when you multiply. When you multiply, you add those exponents. So we have two like variables. An x is the same as an x. So we multiply the x by the x and we add up their exponents. So that would be a 22 added to a 21. Okay, and that 43 is the value of the exponent. So what we have is our final result is x raised to the power of 43. But you don't enter that into the answer sheet, do you? What they want is x to the power of p. What is the value of p? So we're only looking for one number. So presumably you're not bubbling in x to the p. You're actually bubbling in only the value of p. And the value of p is the exponent of x in the second figure, right? Added to the exponent of x in the first figure. The exponent of x in the second figure multiplied by the x in the first figure. When you multiply those together, multiply the value of the exponents in the second figure, that comes out to 21. Again, we will multiply them. And so then we add them when we multiply these like terms, and the value is 43. You can see there. So that is what we would put in our answer sheet. And that was question 34. And we would put in a 43. So Desmos isn't absolutely necessary. In fact, it may not be necessary for most people. But for some people, it helps to have this organized. It helps to show these, to let you mark what you're doing on a step-by-step basis so that you can see clearly and cleanly where the exponent, what the ultimate value of the exponent is. So thanks a lot, Desmos. The graph of linear function k passes through the points -7, 0, and 1, 8. So we have a line made up of these 2 points, and k passes through those points. Which statements must be true, which means we're given 4 statements and only one of them is true based on the graph. All right, so let's start by plotting out our 2 points in Desmos. It is a graph. We can use a graphing calculator. So we have a -7 and a 0. And a 0, and let's not forget to put in the parentheses. Okay, don't forget to label them. We want to see them. All right. So we're going to be on the same line, so we put a comma there to separate the next set of coordinates. The next coordinates are the 1 and the 8. 1, 8. Okay. All right. So, and we have labeled them. And so another feature is, again, you hold down the circle, it brings on your line option, and we have created our line in Desmos. And the question asks you, okay, which of these statements is true about the graph of function k that passes through these points? Okay, so is the first one correct? Take them one by one. The slope of the graph of k is 4, 3. Now I can determine the slope by taking 2 good points and counting the boxes. Let's see, first of all, we have a positive slope. Slope's going up. So if that slope is going up, then we can take 2 good points and we can count them, count our rise over our run. So we can do that. And the difficulty with that is we have to determine that they are in fact good points. So in order not to leave it to chance, because again, sometimes the points, they can go in the middle, we're not exactly sure. So to be exactly sure, we can actually use the formula, which is a little trickier. So I'm going to use what we've used before. The m equals the power of y2 minus y1, and that's in a fraction. And if you forget that, remember that it's in your function chart. This is y2 minus y1. And that is over x2 minus x1, the change in y over the change in x. Okay, so we take the y2, right, it's going to be there. And again, this is a bit more laborious. So, but it's more certain, right? Because we got math to back it up instead of just visually counting those lines. And sometimes our minds play tricks on us. And if this is question number 35, then we're 35 questions into this, and sometimes our minds are not as adept as they were in questions 1 through 5 or 1 through 10. So the value of y2, excuse me, is 8. And we subtract the value of y1, and that's 0. We go down here and we do the same thing. 1 minus a -7. So I want to use parentheses to keep it clean. Okay. Okay. And so we get a positive number, and that makes sense, right? We get a positive 1. Okay. And again, if we count these somewhere along, somewhere we would get a fraction of some whole number over some whole number, and the same whole number giving us the value of 1. Okay, so we look at that, and is that statement true? Okay, so we find out that, well, if the slope is 1, it's definitely not 4/3 or -4/3. So in any case, let's go ahead and continue and go back to our calculator. So we're back at our graph, and we're looking at where those points are, 1, 8, and we have -7, 0. So the next statement asks us, the graph of k passes through the point -1, -8. Okay, so -1, -8. That would be down here and nowhere near it. So we go ahead and we cross that one off. So the next one, the 0 of k is 7. The 0 of k is 7. All right. 0, k is 7. That means the 0 of a line is intersecting us crossing the point of 7. Let's take a look at this line. All right, so 7, that's +7, right? And that's on that side. And so that line is not touching +7. That is not a 0. On the other hand, if we're looking at the zeros, there's one 0 here, and that line intercepts the x-axis, that is the 0, at -7, 0. That means x equals -7. And what does our last one say? Our last one says the x-intercept of the graph is -7. So we're comfortable in saying that that's not true, and this one is. So we look at our answer sheet, and that was number 35. Answer is D. Answer was D. There you go. Desmos does it again. The next question asks you, which expression is equivalent to 210d squared minus 63d? So I'm looking at that, and that seems to be a quadratic equation, and it looks like that because we have our, we'll take a look at the quadratic equation. Okay. And that would be this one here, ax squared plus bx plus c, and there's no plus c, but it is in this format. And something, to complete the equation, you would need a y, right? So that's what I'm looking at. That's what I'm looking at here. Let's go back to our equation. For it to be a full equation, okay, let's copy that over to our Desmos. Okay, let's clear this out. And we are given that 210d squared, we take away 63d. Okay, let's do that. And then one of these has to be equivalent or equal to that equation. Okay, this quadratic equation is equal to one of these and only one of these. So let's go back to the Desmos calculator. Paste that. And it says adding y to the beginning of the equation would be a good idea. And why? Because it's an equation. So it's y equals 210d minus, is that right? 63d. Okay. And we're missing a square, aren't we? Yeah. There we go. Okay, so now we've got that equation. So whatever we get, and make sure you, and again, easy to make mistakes here. Make sure you've got that right. And I put my y because it's an equation. And so that's what our equation is looking like so far. And you can tell what the zeros are in case that's in our question. So let's recreate this one. Copy that, put that into the Desmos calculator, and one by one determine which are correct. Okay, and again, it says, hey, try adding y to the equation. I'm going to add y so that we can graph it. Okay, so look at that one. Look at that one. Is that our first one? Did we get it on the first one? 210d times 10d minus 3. Yeah, the very first one, we've got our same zeros. Remember, we're looking for the equivalent, right? Same zeros, okay? And in this one, we actually have the choices. So we choose, and then we can try all of these, but I'm pretty comfortable. And if I'm wrong, we'll just go back and do it again, or try the next ones. But this question 36, and there's F, the very first one. All right. Thank you, Desmos, for saving us that time. Continuing on in our series of doing the math with Desmos, we are going to continue a state test of the Texas Algebra 1 test. And we begin by showing some artwork created in the Desmos graphing calculator. This one by Samuel Abigbasan of the United Kingdom. And our first question begins with, or about, finding the value of x in the solution to a system of equations printed here. So we are going to solve these equations by putting them into the Desmos calculator. Let's see if that'll work. So let's just try the first equation. Let's put that in there. 3x minus 5y equals 22. So we're given that. Okay. And we want to get that into the standard equation because, as you can see, this equation will not be accepted in Desmos, much less the testing version. So we have to get that into Y format. So let's do that. And we do that by subtracting x from both, 3x from both sides. That'll get Y by itself. All right. So let's do that. If you have scratch paper, it might work. And I encourage you to use the calculator, but sometimes the old-fashioned way helps to just have a place here where you can take notes. And what I'm doing is I'm going to take 3x from both sides. So I'm going to cancel out that 3x, put it on that side. That 3x cancels out. I'm left with this part of the equation. And I'm going to put that in my Desmos calculator as negative 5y equals 22. It's now minus 3x because we took 3x, negative 3x from both sides, or we took 3x from both sides, leaving us on that side with negative 3x. Let us go to the, and we still don't have the equation, so we have to get y by itself. That means we have to divide both sides by y. So if we divide both sides by y, let's do this, and get this out of the way. And now we have this equation, and we're going to take y from both sides. We're going to divide by negative 5 from both sides, both of these, right? A little sloppy there, but you get the idea. Dividing negative 5 by both sides gives us a 1 in front of that y. So it leaves y alone, right? And I can actually put that in my notes. subtract y from both sides, and that gives us a subtract -5 from both sides. No, divide both sides by -5. Excuse me. Divide both sides by -5. That gives us y by itself. Y equals, okay, it gives us this amount, right? And we're going to put this amount over, we're going to put that amount, take a fraction, and we put that amount over -5, right? So let's do that. Let's get our keypad out, put our fraction, and on the top goes what's over there, and we divide both sides by -5. We see it illustrated over here. There's my -5. Okay, and it gives it leaves this fraction intact, but it does give us our first line. Okay, it would be nice if we had the fraction and then minus the 3x and we have it in slope intercept format, but really what we're after is this line. Because remember, we got the graphing calculator and we hope and we expect the graphing calculator to do most of the work and find our values for us, find our solutions to this system of equations, okay? All right, and eventually one of these is going to be able to go in there and we'll be able to solve for both equations. All right, so equation number 2 says y equals -5x plus 32. We got that y by itself, and this one is already by itself. And you see how quickly it generated the line? So wow, that's fantastic. So I have that the solution set is, and I'm going to make a note to myself, solutions are your zeros, right? Let's see, no, solutions are the lines that cross, one line crossing the other, meet at a certain point. That is the solution set to both lines, to both equations. And if I'm saying it wrong, some math teacher out there can put in the comment section that what you really mean to say is, and I would accept that, I would read it and I would learn it and I would go forward with it. But in this case, is the solution set is at that cross. And that is that is 6.5 and -0.5. Okay, I have to keep clicking it again, make sure. 6.5, they meet at 6.5 and -0.5. Okay, let me go back. Yeah, let's see that. 6.5 and 0.5. On the positive side, and we have a negative y, it's going down, -0.5. Okay. All right, there it is. Okay, and it's not going to label it because this thing is in the way, and it's just for me to mark to know. Because if I wanted to look at it, I can just, like I've done 10 times already, just look at it, it's right there. That's my, okay, so I have an x and a y now. I have an x and I have a y. So I have a solution set. And I can just plug that into one of the, or both of the equations actually, right? Oh, let's just do one of the equations. Let's see what happens. So let's see. Yeah, so one of the equations is 3x minus 5y equals 22. That's our original, right? That's our original, right? So we were given that, and we follow that, and we have 3 times, let's do parentheses here, and put, what is my x? 6.5. And then I'm going to take away 3 times 6.5. Yeah, 3 times 6.5. Let's do that first. That's 19.5, right? Because if I do it across, it's going to, yeah, if we try to do this, 5 times the y value of -0.5, we have the danger, and this often happens, that what it does is it multiplies this out by the -5 and then multiplies it. We don't want that. What we want to do is we want to get these, let's see, right, -9. Yeah, let's get these apart. 3 times 6.5, right? Yeah, because it's going to change our value. We can't count on that to hold and say, unless you put some brackets and stuff, and let's make it easier. So we have 19.5 in the 3 times x, -5y, okay? Okay, so those are 2.5, okay. So if I take my 3x, which is 19.5, okay, and if I take away that 5 times 0.5, and actually look, see, I made another mistake. I'm taking away, yeah, no, it's a negative, yeah, gotta be careful here. So I am taking away that 5 times -0.5 value, right? See why it's tricky and why you should let Desmos handle it? Because look at these negatives. They can get tricky, right? Minus a -5 multiplied by a -0.5. That gives us 2.5. Yeah, that can get tricky. So let me copy that 2.5. So if I use these, let's see, you have to have, okay, so we're taking away that 2.5, is that right? Okay, let's see. All right. -5 times 0.5 is 2.5. So, let's see. We've already taken away the -5, right? -5, yeah, okay, so here's what it is. So let's take away that, yeah, -0.5, right, yeah. Ooh, okay, see how confusing this gets? 3 times x, okay, and we're going to eventually take that away from 5 times 0.5, -0.5. So 5 times -0.5, okay? So we have 19.5 minus the 2.5, the -2.5. You see how confusing that can get? Okay. Whoa. All right. So, and I'm doing it with the expectation that it's got to equal 22. It's like it's got to equal 22. 3 times the value of x, as my solution set has been indicated, equals 19.5. We take that away in the original equation by 5 times whatever is y. Our y is -0.5. So that gives us a -2.5. So take your 19.5 and you subtract your -2.5. So that's why this becomes 22, because a negative, taking away a negative, becomes a positive, or these two combine to make positive. So it's 19.5 actually plus 2.5. That gives us a 22, and that works out. And I'm going to stop right there because I've spent a lot of time on this problem, and you can go and figure out the other one on your own. But we're going to go ahead and say that this was number 37. Let's look for that. The answer is C, which is 6.5, which is the value of 6.5. We could leave it there and we could trust that, but we are going to move on. Which graph best represents y equals 10 times 85 to the x? So we caught a break on this one. All those problems like that having to do with those solutions and that stuff. Let's do away with that and just get an easy graphing problem, because all we have to do is enter that, raise it to the power of x, and it graphs for us this figure. It crosses the 10, it crosses the y-intercept with 10, and it crosses the x. It seems to touch, just about touch at, I think, 30, 35, maybe something like that. It's more like 35. Okay, so we just need to get we just need to match that up to the, yeah, we just need to match that up. So looking right here, we're looking at, right now we can already eliminate the ones that don't go in that direction, right? Okay, so let's go ahead and already eliminate the ones that are going in a different direction, such as this one. This one is going in a different direction, right? And yeah, this one is going in a different direction. We can get rid of that. Right. Okay, so it's not F. Okay, what about these? This is also going in a different direction in a different quadrant. It's not H. So it's between these two. And I'm seeing that this one touches at 10 and goes all the way down. Somebody can kind of zoom in on that. Okay, and it doesn't show us where it lies, but go ahead and look at that one. That really doesn't match. So I'm pretty confident that that's pretty much our calculator, right? And I'm going, and that is choice G or G, right? G, so I'm going to choose G and this one. That was number 38, was it? The answer is G. Correct. Thank you, Desmos. See how we do that one. The table shows a linear relationship between X and Y. There's your X column, there's your Y column on a table. And as always, I encourage you to create the table, even though you may not need it. You may not need it, sure. But go ahead and create it anyway. You have the time. Here's the question, and based on the question, you may say, I really don't want to do the table, but again, I still encourage it. What is the rate of change? Oh, before I even go halfway, rate of change in Y over the change in X, all right, our slope formula. And what is the change of Y with respect to the change? What is the change of Y with respect to X? All right. So again, may not need this, but I'm in the habit of doing it. I want you to be in the habit of doing it. Plus, create a table, negative 20, 12, 6, and 2, negative 20, negative 12, negative 6, negative 2. Let me double check those, right? And then I have 96, 60, 33. And 15. There we go. What kind of an solution, what kind of an image do I get? There we go. Oh, I haven't done my line. You have to switch that line on. There you go. Okay, so that's the kind of line you get. And again, you can take points and count them, but again, I don't immediately see clean points. I might go fishing around for those clean points. But by the time I find them, I can just go ahead and do my M equals the change in Y over the change in X, Y1 minus Y2. Let's do Y2 minus Y1. Keep forgetting that. Okay, over X2 minus X1. Okay, and so I'm going to go over here and see what this gives me. Y2, let's get the first Y2 with 15. 33. This is X2, X2, X1. Okay, so X2 is negative 2. It's the first set. Remember, you just want to take the first set here and the next set here. All right. Some of you have a strategy of trying to get big numbers and small numbers. Okay, it doesn't always work. And minus 6. Get my ruler. Minus 6. Right. Okay, so 15 minus 3 minus 33. -2 minus -6. Okay, and it understands, in this case, it understands that the m is the slope that you're looking for because it understands that you had a y1 and a y1 and an x1, and it understands based on these numbers here. Let me make sure that's correct. x2 over x1. Yeah, it still understood it. That your slope is -4.5. All right. Okay, and let's see if we did it right. We might be able to find that here. Okay. All right. So we might have done something wrong because I'm not seeing. What is the change in y over the change in x? Let's make sure we did everything correct. And I have. Let me look at them once again. So we look for those numbers. Okay, I don't see them. And okay, here's something we can try. Yeah, okay, there we go. So according to this calculation, if we did it correctly, it's -9 over 2. Notice we changed it. We didn't see it immediately because it was in a decimal format. There it is in fraction format. And it wasn't in fraction format. That's the answer. So you want to look for that. Other calculators have a function also where it says convert or approximate to a fraction. That is A, and I'm going to go ahead and choose my answer. I think that's 39, and the answer is A. And so Desmos, pretty good about doing a lot of the work. I encourage you to use it. So let's do one more for this segment. Which value of x is a solution to this equation? Okay, we can go ahead and plug in all of these in this equation, but you know I like to use, and I like for us to use the decimal calculator, the Desmos calculator. Let's go ahead and plug that in, see what we get. All right, let's make sure we copied it correctly. And we have 5x squared minus 6x plus 36 equals 0. That is very close to the quadratic equation formula, the first one you see on the chart. You can go ahead and remember that. But remember what I said in an earlier, we take this, we want to put it in y equals equation format. So that means without changing any of the signs right now, let us, let's do this. Sometimes this works. Okay, so this gave us a line. Let us see what happens when you do y equals. Yeah, it's the same. So it's putting it in that y equals format. All right, so you may not need to put it in y equals format. I like to do that in case I don't get the graph. So in this case, I got the graph. Okay, so the question is, which is a solution? I guess we could plug in -6 into that. We would have to solve this. Let's take a look. Let's make sure we're not missing something from the question. And so I'm looking, yes, I missed, it's a quadratic equation. It should look like something x squared, right? Or something squared plus, okay, so big mistake there. You want to keep double checking these, okay. And so that gives us a parabola. Quadratic equation should give us something that looks like a parabola. So what that does is, it gives us the zeros, doesn't it? And again, if we don't have the y equals, we still have that format, we still have that expression that gives us the zeros, okay? So I like my equations with y equals the quadratic equation. I like to see that I have my zeros, which is where x is intercepted. So how does that help us? I have 1.2 and I have 6. I have 1.2 and I have 6. X equals, so my zeros, taking notes here, are x equals 6 and x equals 1.2. All right, 1.2. So that information is good. I have my, if I need to, I will look for my axis at 3.6, and sometimes it asks you about the axis and the axis and the vertex. A lot of terms to remember, but in any case, this one is asking for a solution. A solution is referring to the zeros, the solutions at which x is your equation, your line, your parabola crosses the x-axis. And again, math people out there, if I'm wrong or if there's a better way to explain that, put that in the comments and I will edit the video accordingly. I want to get the best information out there as possible. And so, and just hold off on those comments, the people that are using a rival calculator and saying, you see, if you use brand X calculator, this wouldn't happen. Okay, so I'm seeing that I have something in F that says x equals -6. In fact, I don't have a -6. I go down and I'm looking for a solution that would be true, something that would be true, x equals 4. I don't see that anywhere in the calculator. Not up, down, not down, okay. I have an x equals 1.8. I don't remember seeing that. I have an x equals 1.2. I do remember seeing that. X equals 1.2, that is one of my zeros, okay. I might think that that is my solution, and I'm going to wrap it up by choosing J for now, and then double checking it later. Once I'm finished with the test, I can go and double check these, right? Okay, and I can leave all of these lined up there, piled up, but it would be hard to look through, but at least you'll have them to reference later. In any case, number 40 is J. There you go. Thank you once again, Desmos. Does it for this segment of Doing the Math with Desmos. Join me at my YouTube channel, which is going to be posted at the end. Please consider using this calculator the next time you take your exam.